Hello, today we're looking at the area of special shapes. Just a reminder from last lesson that area is the two-dimensional space inside a shape, and that we measure area using square units such as millimeters squared, centimeters squared, and so on. If you watched the last video, we learned the area formulas for 4 very common shapes, so if you don't know these shapes already, make sure you go back and watch that video. Apart from that, let's learn the formulas for some new shapes. So we've got 2 new shapes here. We've got a rhombus and a kite. Now a rhombus is just a square that's been pushed over, so all edges are still the same length, but it's on an angle. So if we call this diagonal x and we call this diagonal y, if you want to find the area of a rhombus, it's half times x times y. Now what's interesting, even though a kite is a different shape, a kite is kind of a rhombus that's been rearranged in a weird way. So if we have diagonal x here from corner to corner, and we have a diagonal here from top to bottom, we can still use the exact same formula for a kite, half times x times y. So if you're ever doing any rhombus or kite questions, they will use the exact same formula. You just need to work out what those diagonals are, multiply them together, and then half your answer. Okay, here are some quick examples. So with the rhombus up the top, it's got a diagonal of 5 and of 7. So half times 5 times 7 will be our answer. So in this case, it's 17.5 meters squared. For the kite down below, we're just going to use the exact same formula. So we're going to go half times 5 times 8, because those were the 2 diagonals, and we'll get 20 meters squared. So just remember, if you're ever finding the area of a rhombus or a kite, they just use the same formula, half times x times y. Alrighty, let's look at the trapezium. Now this is a shape a lot of students have trouble with for some reason. I think it's just because it's a bit different, but let's go through it. So the longest side here at the bottom is called A, and the matching parallel side at the top is called B, and the distance between them is called height. So this is your normal looking trapezium. But trapeziums can look different, okay? They can be rotated or look a bit weird. For example, this shape on the right is also a trapezium, even though it has 2 right angles as a part of it. So in this case, the longest side would be A here, and the matching parallel side would be B. So whenever you're doing a trapezium, you're looking for those parallel sides and you're labeling them A and B. And then the height of this one would be going across here. So the distance between A and B is the height. So please note, even though these look different and one's on its side, these are both trapeziums and the formula will work for both of them. So here's the formula. It's half times A plus B times H. So the first thing you must do is add the parallel sides together, A plus B, then you half that and then you times by the height, and that will give you your area. For example, let's try this question here. So I can see that the longest parallel side at the bottom here is 4.5 centimeters, and the one at the top up here is 2.5 centimeters. So I'm going to add those together, then I'm going to half the answer, and then times by the height of 1.5. So substituting into the formula, we're going to go 2.5 plus 4.5, add those together, half it, and times by 1.5. And if you type it in right, you'll get 5.25 centimeters squared. So just remember, add the parallel sides together first, half your answer, and then times by 1.5. So you might come across some circles and sectors when working with area. So the formula for a circle is pi times radius squared. It's a pretty easy formula to remember. So just pi times radius squared. And when we're working with sectors, it's the same formula, but we just put a fraction in front. Whatever fraction of a circle we have, we times that by the area. For example, if you look at the circle on the left, it's got a radius of 7 meters. So we're going to go pi times r squared, or pi times 7 squared, and using our calculator, 153.94 meters squared would be our answer. If you look at the problem on the right, we can see this is a sector with 190 degrees. So, using the formula, 190 out of 360 times pi times 4 squared will give us 26.53 millimeters squared. So again, they're pretty much the same formula, just with the sector, you put what fraction of the circle you have in front. Thanks for watching. Hopefully you can remember those formulas. If you have any questions, let me know down below. Apart from that, have an awesome day.